day 6.5, we're going to review factoring with diamond problems, and we're going to learn about multiplying binomials. So for the warm-up, I just pulled a few review problems. The first one is a list of numbers, a sequence, and the question is it arithmetic, geometric, or quadratic? And then how do you know? So if you take a look at testing to see if it's arithmetic, you'd see, is there a common difference? Is it adding or subtracting by the same number every time? So to test that, we could say, all right, how do you get from 7 to 9? You would add 2. Is it adding 2 every time? So 9 to 13, that would be 4. 13 to 9, that would be adding 6. And 19 to 27, that would be adding 8. So we can see that it's not arithmetic. Geometric, we can take one number and divide by the number before it. So if I try 9 divided by 7, it's about 1.2857. I'll try 13 divided by 9. And I get 1.44. So again, if you take any number and divide by the number before it, you should get the same ratio, and we don't, so it's not geometric. So then the last thing we check is it quadratic? And if it's quadratic, the second difference is the same. So if we take a look at these numbers I have in blue right here, the first difference, we would see, all right, is it increasing or decreasing by the same amount, by adding or subtracting by the same amount? And to get from 2 to 4, you can add 2. 4 to 6 you would add 2, and 6 to 8 you would add 2. And so this would be quadratic because the second difference is the same. So that would be the answer for part A. For part B, what is the vertex of the following quadratic? And we know that's going to be the opposite of what's inside the parentheses, because this would be left 5 and then down 9. So there's the vertex. If we were to graph it, you would go left 5, down 9 somewhere, and this is what it would look like. And see, what are the zeros, x-intercepts, and roots of the following quadratic? And this is where it crosses the x-axis, and we want to know what makes each one of these 0 using zero product property. So 7 would make x minus 7 0, because 7 minus 7 is 0, and negative 5 would make x plus 5 0. So if we were to graph this quadratic at 7, there would be an x-intercept, and at negative 5. And so our quadratic would look something like this. So those are the x-intercepts. So then what we did yesterday, factoring with diamonds. So we want to get it into factored form so we can see what the x-intercepts are. And so if you have this thing, this is called standard form where there's no parentheses. You can make your diamond. The last number goes on top. The middle number goes on the bottom. And the middle number has the x next to it. And we want to know what multiplies to 8 that adds to negative 2. So some factors of 8 are 1 and 8. 2 and 4, and we can get 2 and 4 to add to negative 2 if we make the 4 negative. Whoopsies. So negative 4 and 2 would multiply to negative 8 and add to negative 2, and we would have x minus 4, x plus 2 would be the factored form. So this is factored form. I'll put FF, factored form. If I asked you to solve the quadratic, like to find the x-intercepts and to graph it like this, the x-intercepts would be 4 and negative 2. So these are the x-intercepts. Okay, let's try the next one. Let's just factor. So we'll make our diamond. The 10 would go on top, negative 7 on the bottom. What multiplies to 10 that adds to negative 7? And that would be, let's switch colors here, negative 2 and negative 5. So just the factored form would be x minus 2, x minus 5. So then it says we can find the zeros or x-intercepts. Okay, so we can factor to find the zeros, x-intercepts, and roots of these quadratics. And again, same name or different name for the same thing. These all mean the same thing. Let's sketch it below. We did the first one already. So if we have x minus 4, x plus 2, the x-intercepts are the opposite because that makes each factor 0. So for this first one, there would be an x-intercept at 4, and there would be one at negative 2. So if we were to sketch this right here, I'm not going to be worried about the vertex for this one if I want the x-intercepts. It would look something like this. All right, our other one, we have x minus 2, x minus 5. Again, this is factored form. Put FF. But if we want to solve it and find the x-intercepts, we would say, all right, what makes x minus 2 equals 0? And that would be 2. And what would make x minus 5 equals 0? And that would be 5. So if we were to graph this quadratic, the x-intercepts are at 2 and 5. and your quadratic would look something like this. Okay, so that is review of what we did yesterday. So today we're going to go backwards. Today we're going to have factored form, something like this, and we're going to turn it into something called standard form, which has no parentheses. So that'll be our goal. Okay, so let's take a look at the first one. It's called multiplying binomials. By, the prefix by means 2. So it says Brennan has a square garden. He wants to increase the length of it by 4 feet and the width by 3 feet. A plan for his garden is drawn below. So here's his existing garden, x by x feet. It's a square, so 2 sides are the same. We're going to increase the length by 4 and the width by 3. So now it says write the expressions for the area of each part of the garden. So we know that if it's a square, a rectangle or square, that the area is base times height. So the area of the existing garden x by x would be x squared. For this one, it would be 4 by x, or 4x. For the tomato part of the garden, it would be x by 3, or 3x. And then for the little carrot part of the garden, it would be 4 by 3. 4 times 3 is 12. So each part of the garden would be x squared, 4x, 3x, and 12. And then for the total area, we're going to add those together. And when we add them together, you can only combine like terms. 4x and 3x is 7x. So you have x squared plus 7x plus 12 would be the total area of the garden. And what we just did is we multiplied binomials. The two binomials that we multiplied were this x plus 4 and this other one, which is x plus 3. We multiplied those together, and that's in factored form right here, to get this thing called standard form, where you don't have the parentheses. So again, called multiplying binomials. Another way that you might see it asked of you to do this, like multiplying binomials, is it says expressed as a trinomial or 3 terms. So this has 3 terms right here. And right here we have binomials, so 2 parts. Right here we want to multiply it together, and we're going to get the trinomial. So to do that, when we multiply, we can do like what we did up here with the garden, use the area model. And so I'm just going to draw some rectangles here. And we have x plus 3 times x plus 5. And like Brennan's garden, we just want to find the area of each section. So in our first section is x times x, which is x squared. In our second section, it's 3 by x, or 3x. In our third section is x times 5, or 5x. And in our last section is 3 times 5, or 15. And then when we write it, we want to combine like terms. We can't put anything with the x squared, so we'll leave that. But we have a 5x and a 3x, so you can add those together to get 8x. And then we have our 15. So there is our trinomial 3 terms when we multiply the 2 binomials together. All right, let's just do a few more, and this is the one thing that we're adding today to some review problems from yesterday, is the multiplying, or expressed as a trinomial. So let's try the next one. We have x minus 7. I should draw my rectangle first. And x plus 2. In our first box, it is x times x, which is x squared, negative 7 times x, which is negative 7x, x times 2, which is 2x, and negative 7 times 2, which is negative 14. So then we'll combine like terms. Again, we can put the x's together. So we'll have x squared, and then negative 7x plus 2x is negative 5x. And then we have our minus 14, and there's our answer. And then our last one, notice there's some numbers in front of the x. We can still do the same thing that we've done before. We'll make our rectangle. We'll do 2x minus 4, 3x minus 1. Doesn't matter which one you put on the top or the side. We'll get the same answer. And then we'll multiply. So we have 2x times 3x. You'll multiply the numbers together first. 3 times 2 is 6. And x times x is x squared. Negative 4 times 3x is negative 12x. 2x times negative 1 is negative 2x, and negative 4 times negative 1 is 4. So there's what it looks like. We'll combine like terms right here. We got 6x squared minus 14x plus 4, and there is our answer. So our assignment today, we're going to review the stuff from yesterday, the factoring, by using a diamond problem, and then we're going to add some multiplying binomials, and there's some review of what's the vertex of the quadratic as well. So you're going to log on to Delta Math and complete that for tomorrow.